Alright, let's go over now probably one of the most useful tools that when it comes to creating threads. Like I said before, SolidWorks 2016, 2015 and lesser, you had to do it by creating a basically a helical coil on a surface. If you want to do a um, external thread like a bolt or a screw, you have to create a cylinder on the outside and then do your helical coil and then do a profile of the I guess you could say cross section of the threads that you're going to cut, and then extrude cut that along that profile. And the same thing goes if you had a hole. Usually you choose the major diameter of the inside and then do the same thing, but that would be for like a tapped hole. And like I say, back then, usually you would also just, do cosmetic threads. So you wouldn't do the threads because it would take too much, I guess you could say, computer computational power. But what happens if you want to actually do it? So the one thing we can do, okay, I actually constructed this little, double cylinder, one with a, the inside's cut out on one side and then extrude on the other side for basically M20. One thing you'll notice when you're using the actual tool, it's basically define the whole wizard thread. But when you're using regular standard threads, it's much better if you, for like I say, if you're doing external threads like on the outside of a bolt, then you want to pick the major diameter of the actual bolt. Let me see if I can pull up a picture here. Pull over here. So your major diameter of like the bolt, they're calling this the male and female, but that's the old terminology. So you want the I go for the major diameter on the external. So like this is a M20. We want to make a M20 thread metric, so I made this 20 inch or 20 millimeter diameter. And then if you're doing an internal, if you're tapping a hole, I would go with the minor diameter on the inside one. That would be the, because you're going to want to have something to cut. So when I do the major on the outside, it's because I want the maximum amount of material and then cut away what I don't need. On the inside, I want the basically kind of similar, but the minor diameter, which would be the smaller portion. It's kind of the opposite thought. I want that so I can cut away on the inside, tap the hole. If you're using a metric tap where you drill, you have a certain size drill, you drill through and then you tap that. So it's basically I would go with the minor on the other side, which on this part, the D2, see how it's kind of the opposite. If this were the external, this would be the major, but on the inside, the minor is kind of like the opposite. It's where it mates up. So with that said, go down to a chart, whatever, and I try to pick, for the external, your thread M20, your major diameter, of course, can be 20. So just whatever size thread you're going for, or screw, 20, M20, M18, M14. Just pick that as your cylindrical outer diameter. When you're drilling holes into something, I usually take the minor diameter. So for M20, come over here. The minor diameter would be 17.294. So make that 17.294 will be the inside what I'm going to cut out, and that way it helps. That's the when I start cutting, when you tap in, that's the size of the hole you can drill, and then you're basically removing material in between that and the outer surface. So that'd be the minimal size that you need to start the tap. If that makes sense. So let's just get to it. All right, let's start with the external. Start your hole wizard, and you're gonna go to thread. you're always going to have this warning, whatever thread tool type and size profiles are nominal thread profiles only. Do not use them for production quality threads. To create production quality threads, modify nominal profiles to meet your design requirements. That's dependent on exactly, these are kind of the basics. Depending on how tight tolerances you want, you're going to modify, I guess, the thread profile to your liking. So these are just the basics that'll get you there. So if you come over here, you've got your thread. Thread location. Since I already created this, I can start from the top and work my way down from the bottom and work my way up. Let's go from the top down because I want to screw this into something. Maybe this side would be being able to go into a nut. So there's edge 1. Now we can do offset. An offset would be, do I want to start the threads above it or below it? Let's say, this is going the opposite direction. If you want to make sure that your threads are actually engulfing, because see, if I start it right here, it's going to have a sharp edge. You try to actually use this for an actual thread to cut into something. You can get stopped right there. So, that's the way you get around that. Like say you offset and then give it maybe, depending on the size, whatever. Let's say what size is this? It's the 1-8 inch die, 8 threads per inch. So we're in millimeters. So let's actually go inch metric die. Okay, when you're saying die, the difference between die and tap, die would be the outside. Of course, I want metric die, outside. Like threads, external threads, and the tap would be in a hole or like on a nut, but drilling a hole and you tap the hole. And I made this exactly for the size for an M20. We got a 2 choice, M20 1.5 or M20 by 2. That'd be 20 threads per inch, or not 20 threads. 1.5 is our pitch. What am I saying here? Gosh, it's been a long day. So once again, our offset sets it up and down. I guess you could do a surface. And selecting a surface is, you got an edge, and then you can select a surface. That gives us our profile. If you want, you can always select, let's say I wanted to start down here, it'll just transfer it to where you want. I'll have to have that and don't have to have offset, but I'll keep the offset for right now. Actually, since it's a 20, let's do a 20 1.5. So technically 1.5 should be enough to put it right above it. And then, okay, your degrees is kind of like your offset angle that we have like in helical coil, where you're going to start. This so you can set up to start on anywhere. Right now it's set up at 0 degrees, which is right down at the bottom. But let's say you can increase this. And notice how as I increase it, as I stop, it shifts over. So if I want to start at 90 degrees from there, it just shifts over. Notice how the bottom shifts also. So our end condition, let me start back at 0. So that basically angle there is just how you're shifting, where you're getting that, where you're starting that first cut. So you got your condition blind revolutions, kind of similar to the helical coil. You set it has as many revolutions as you want. Sometimes when you are basically doing a, like I say, a threaded hole, or it's through something you need a certain depth, you can and a certain depth depend on the strength of the connection between the bolt and the nut. A certain amount of threads you need engaged to have the maximum strength of that nut or the bolt. So you can set that up with revolutions. Or you can do like up to selection. So I went from there to, let's say here, all the way down. Let's just work on blind real quick. I'm going to do it for 15, all the way down. All right, the maintain thread length, when you select that, what that is doing, it's actually taking into account your offset, 1.5. So and we did it blind, we wanted 15 millimeters of thread, but since we did an offset upwards, if you do maintain thread length, that'll ensure that you have, based from the top surface down, you have 15 millimeters of thread. Or I can double verify that. So I went 3, if I offset by 3, now I should see it go down 3 more millimeters, and there it goes. Went by 2 more, I guess, rotations. You know, the pitch of 1.5, so I went down 2 more rotations. I go back to my 1.5. So, so now we're back down here at our specifications again. Just go over that real quickly. Where you have your inch die and your inch tap if you're working with, you know, inches, you know, 1/4 inch -20 or some other form, whatever. Remember, the die is the external, the tap is internal. Same thing with metric die, external, metric tap, internal. Now, these parameters here are already set based off of what you selected here. So, all right, you have your, like I said, your thread method here. Everything's based off here. When you do, we're doing cut thread. You know, we did the exact major diameter, so we're wanting to cut into our protrusion, our cylindrical protrusion, to make the threads. Extrude thread would be actually adding; it wouldn't be cutting. So that would just be adding material, and that would do pretty much absolutely nothing for us. But one thing it could do, let's say we were doing a cut thread, but when we do a mirror, this is just going to cut air. But if we did extrude thread, extrude thread, it would create a, you know, the reverse profile backwards, but on the outside of the cylinder. If you ever need to use that, and you can mirror it. That's horizontally. You can mirror it vertically. But we're not going to do that. We want to do cut. So the main purpose of this, you know, you're going to, the main use you're always going to use it for is, you know, doing external threads. And the same thing, you could do an angle. And when you're doing the angle on this, it's actually doing a, see how it's twisting it upwards? Oops. Let's just go back to 0 degrees. Locate profile. In case for some reason you haven't, you know, sometimes you have, you know, you're all spun around, or, you know, it's a really long thread, or it's really fine. You're like, where's my my profile? So you hit the locate profile, it zooms in for you. It doesn't rotate it for you though, but it'll zoom in for you. All right, under thread options, we have, you know, right-handed thread, left-handed thread. Mainly everything's right-handed thread. You know, using your screwdriver, or, you know, bolt lefty loosey, right tighty. Going clockwise, you're tightening. Counterclockwise, you're loosening. Sometimes you'll come across things, especially like, you know, if you ever guys have worked with like a radial saw or something like that, putting the saw blades usually on. Usually you'll have reverse threads on those, because the way it's spinning, you want to make sure that the threads of the bolt or the nut that holds it on is the opposite of the rotation, so it doesn't just spin itself off. So also on the thread options, you have right-hand thread, left-hand thread. You have multiple start. That just is, you know, depending on how many, you know, locations you want that thread to start. It's kind of overlapping. Don't really see too much of a use for it right at this instance. There's probably some uses for it. Trim face, the start, that kind of you know, trims it right at the upper limit, which is good. Trim face with end. If I had this going all the way down the bottom, or if it actually cut into the bottom, it would actually do the same thing and make it nice and flush with the bottom. And of course, you've got your preview options, you know, shaded preview, wireframe preview. Actually, let me see, different variations of the wireframe. You can have it thicker lines or thinner lines. Might as well go with the thinnest. And then, of course, partial preview just gives you a simple helicoil with the profile. So that's the main portions of, I like my shade preview, of the thread for an external thread. So let's, actually, you know what, let me do the trim face start and then hit OK. Now we have a M20-1.5 thread. Now, when I was talking about the the same thing with, if we go back to this over here, I only did one side with the domed it. Now on a thread, you kind of don't want to leave it straight like that. What you could do is just do a similar, draw on this flat surface here, and then extrude cut. Let's just go through that real quick to make it look better. So go to your sketch. Let's just do a so now we got the sketch. Let's go to our extrude cut. Come straight out. And that makes it look a lot better. So that is your external threads. And since we cleaned up the bottom portion, we might as well clean up the top portion too. Probably the easiest way, you basically do a chamfer around the corner, but in order to do that, we're going to have to draw on, let's see, probably the front plane. Which plane am I on? Da-da-da. Front plane. Let me see. Front. Yes. What I'm going to do is, let's see if I can, oh, I know. Here's an idea. Let's do a, oops, reference geometry, insert. I gotta get back out of that. Okay, yeah, what I did is actually added an axis. I had to get out there real quick and added a reference geometry axis right down the middle. That way I can select across, create a construction line out to the end. Now we can actually do by hand a chamfer. I'm going to do it a little bit farther out, make sure I encompass everything. Now, let's see. We do a 2x2 by 45. Now this is just for looks. Actually, let me do one. And like I said, this is actually not going to be an exact chamfer. Oops. Like I say, this is just for just for looks, to get rid of some of these sharp curves up here. And let's do a revolve cut. And delete. I want the axis of evolution to be this one. So that smooths out the curve all the way around. That's just one method of making it look good on the very tip.